lactating mammal glands. Okay.
Resting and lactating.
So this one is quite easy, right? For the resting mammal glands, you see the lobules. Okay, around the lobules there are a lot of connective tissues around. Okay. And for the lactating mammal glands, you just see swelling. Okay, lobules connecting the next lobules, and in the latiferous duct, it's full of. Okay, so this is one. This is I told you is from age, very old female, and this one probably from a younger one. Okay, so you can see. You can see the lobules like this. Okay, latiferous duct is still well developed, like this one. Okay, they have any chance to be reactivated again. The early one probably has no chance to be reactivated. You just see huge, okay, development of those collagen fibers.
That's the lobule, right?
The whole thing is the lobule. So this is lobule. This is a large lobule. You can see latiferous duct inside, but it's empty, right? See, it's empty, empty. This is lobule. Okay, connective tissue. Sounds very clear.
So this is the inactive mammary gland?
You can call it inactive or resting mammal gland. Okay. Then someone have a baby, and then now you see the changes. Okay. So this case is somebody who's feeding a baby, lactating, active, big difference. See, I move around, everywhere is the lobule. You still see the interlobule space, but it's like this. Now, the latiferous duct is full of contents. Okay, if you look at it carefully, the milk, latiferous ducts. Okay, and the lobules, well developed. Okay, and all the cells are enlarged and they are doing active synthesis. You can see those white bubbles, or the vacuums filled with synthesized materials like milk, proteins. Okay, fat mostly come from when the cells pinch themselves. Okay, the cell membrane that contains phospholipids that forms the majority of the fat, which is needed by the baby to synthesize the baby cell. Okay.
What's the difference for glandular alveoli?
Glandular alveoli. So this glandular alveoli are these circles. Now I go to high power. Okay. So all this are glandular alveoli. See the circle? See the circle?
Circles within the,
Within the lobule.
okay.
Glandular alveoli is within the lobule. Look at this. This is one. This is one. This is one. This glandular alveoli also has a lumen. See that? When half of the cells are pinched off, this is actually tubing connecting to this. Okay? So the gradually descending to this, and this connecting to the larger one. Alright?
Will you test us on that?
The alveoli? Maybe. Okay. Mostly I ask, one slide we ask 2 questions. One is ask you all the stage, and then I ask you what is the pointed structure. 80% of the questions ask you what is the pointed structure. Okay? Alright, so that's for the test is I'm going to test you on this magnification. Okay? So it's like this. The first question asks you, well, I put pointer like this. Okay, pointing to one of the cells over here, and ask you around the points, this circular structure. What is the name of this structure? Vas deferens? No.
To know?
The circles. What?
The seminiferous tubules.
Seminiferous tubules. Yes, seminiferous tubules. Okay. So you have seminiferous tubules, and then I point to the cells over here, and I ask you what type of cell it is. Like you see several cells here. This is a blood vessel. Okay, this cell, this is nucleus, interstitial Leydig cell, interstitial Leydig cell, seminiferous tubules. Okay. Vas deferens is the one carries the sperm. Seminiferous tubules is the one that produce the sperm. All the sperm is produced from here. Okay. Any question? What's your question? All right. Somatic cord, the only thing I'm going to test you is this. Is this. That's the vas deferens. Okay? The whole thing is somatic cord around. So this thing is vas deferens. Okay? So it has epithelium. Okay? Maybe I use this one, if I use high power, will give you things like this. Like this. I probably will leave some sperm visible, okay, in the field, so you can see the sperm. And then I ask you this: what type of epithelium lining the vas deferens? Pseudo stratified ciliated columnar epithelium. Okay, similar type of tissue found it lining the trachea. All right. So may I ask you for this question? And I ask you the organ's name. Okay, it's vas deferens.
So the vas deferens is like the whole circular?
The whole thing. Okay, this
Is
whole
this
thing
turned
vas
on?
deferens.
Dr. Zell,
Uh-huh.
is this thing turned on? Could you turn it on somewhere?
No power?
I don't think so. Is it- Oh, never mind. It's on. I just didn't press this power.
It's
I'm
on?
sorry. Yes.
Okay. So this whole thing, okay, now I put it at low power, okay. So this whole thing, okay, that's the vas deferens. Okay, this is the lumen, and you see several layers of smooth muscle circling around, which is stimulated by the sympathetic nervous system. Okay, sympathetic nervous system they contract, squeezes, the sperm comes out. Okay. So that's the spermatic cord and spermatozoa. This slide is very easy. I just give you, actually give you 2 points for that. Okay? So you just see the cells like that. You just say, okay, this cell or spermatozoa. That's it. Okay, so that's the most easy 2 points. Yeah, prostate glands. For the prostate glands, I will show you the glandular villi, and also I will show you these concretions. Okay, prostate concretion, maybe at this power, so you can see more glandular villi and the multiple concretion. You just say this circle for glandular villi, so one of the circle, okay, and this is the concretion, all right. The whole organism, okay, the whole organ is called prostate gland. So that could be 3 questions to ask you: glandular, okay, villi, and concretion, okay, and then the organ's name is prostate gland.
What
All
was
right.
the concretion again? I'm sorry.
Huh?
What was the concretion again?
Can you see this pink
Yes.
structure? Mostly it's the calcium crystals. Okay, calcified structure. So that's prostate gland for the development. Okay, unfertilized egg will be asked. Oh, perfect. You can see. There is a unfertilized egg over here that cut from the middle. So you can see the nucleus and the nucleolus. Okay? Can you see this one? Okay. So you can see two-cell stage. Okay, this is unfertilized egg. You see the nucleus and at the same that this is black dots. Is nucleolus. Can you see that? Okay, it's a little bit fuzzy. Okay, so this is 4-cell stage, 2-cell stage, 4-cell stage. Okay, unfertilized egg. What is that? It's morula. That's good. Okay, it's morula. Okay, and I'm going to show you a blastula. So this is a blastula. Okay. See the blastula? You can see the hollow space has been developed. Okay. And I will also show you a gastrula. Okay. I will see if we can find some in these slides. Okay. So this slide is for the early stage. Okay. No gastrula. Okay. 2-cell stage. Okay. There's another 2 unfertilized there. Okay, nucleus. So this is one of the slides. Okay, early stage. So I will find the late stage, that is the gastrula. I'm going to ask you the opening of that blastopore. Okay? So this do not have a good one, but there is a couple of gastrula over here. Okay, let me show you from this. Okay, this one. It's a bit fuzzy over here. Okay. For example, I will ask you the space. It's blastocele. Okay. The opening. Blastopore. We ask you what's the future structure of the blastopore. You say anus. All right. Anus. Okay. And the one I'm going to ask you, for example, we have. Okay, I probably will find the one like this. So I ask you this, okay, this is the blastopore, future anus. This is one question. Another question, I will put the arrowhead over here like this. I ask you the tissue, ask you the space first, okay, the space around the pointer. You say this is blastocele. If I ask you the tissue, left or right of the arrowhead, if it's left, this is the future endoderm. If it's the right, this is the future ectoderm. Okay, future ectoderm. Okay, so that's going to be the. If I point to this, this will be future mesoderm. All right. So we already selected the slides that has one of the embryo like this, okay? And those questions will be asked.
Okay, so the left is the endoderm and
this portion will be form the future endoderm. This portion will be form the future ectoderm. You got that?
What did you say, mesoderm? That was,
The mesoderm will be this part. This part.
So are you gonna be testing us on that even if it wasn't on there?
Uh-huh.
Okay.
So for the embryo, as I told you, okay, you need to know what is the morula and the blastula. You need to know what is that's the egg. Like I show you one cell that has nucleus in it, okay. You need to know what is the gastrula. So this is gastrula. That's imaginated from that structure. Blastula is just a ball that has empty space. Blastula, okay. Without, okay, the hollow space is a cell form a ball. That's the morula. That's how you tell them. Then the blaster pool, okay. The future of the blaster pool will develop in Giannis. You need to know that. You need to know the space. This whole space is called blastocele, okay. And the gem layer will be developed in the future. Ectoderm, mesoderm, and endoderm. That's the question you need to answer for the development. Okay? Placenta slides is quite easy. We just ask you the villi. Okay? Chorionic villi. That's from baby's tissue. Okay, so I probably give you slides just like this. Okay, the magnification may be like this or like this, but it's almost the same. If you look at this, okay, I just maybe pointing to this or to this space. Ask you what is the name of the space? Okay, that's intervillar space. Okay, filled with mother's red blood cells. So those are mother's red blood cells, and this
can you
is.
focus the image?
Huh?
Can you focus the image?
That's better? Okay? So, those are villas, chorionic villa. The baby's blood vessel inside, the red blood cells inside from baby's blood vessel outside, that's filled with mother's red blood cells. Okay? If I ask you the whole organ's name,